three geometric sequences and finite and infinite series. Um, so, just like yesterday, we talked about um, arithmetic sequences and series. Today, we're going to talk about geometric. The difference between the two: arithmetic, you add or subtract the same value; geometric, you multiply or divide the same value. So, a sequence where the ratio between two consecutive terms is called R, the common ratio. So basically, if I'm multiplying by the same value, that tells me it's geometric. If I'm not multiplying by the same value, it's not geometric. Arithmetic, add and subtract; geometric, multiply. So is this given sequence geometric? What are you doing to get to each term? So yes, it is. And R equals 3. Your common ratio is 3. What about this one? From 96 to negative 24, what did I do? Divide by negative 4. To get to 6, what did I do? To get to negative 1.5, what did I do? So it's geometric. And R equals negative 4. Um, negative 1/4. Because you multiply. So it'd be negative 1/4. With geometry, you're always multiplying. I know I said multiplying and dividing, but you're actually always multiplying. It's a fraction if it's decreasing. So right here, a geometric sequence has a sub 1 equals 4. That's your first term, and R equals 6. What is the fourth term of the sequence? Well, the first term is 4. So what's the next term? After that? After that? Wait, it's 24 times 6, not 4. 24 times 6 is what? Multiply that times 6, you get. That's your fourth term. Any questions about that? Yes. We're getting there. We don't really care about all that. So the formula for a geometric sequence. A sub n equals a sub 1 times r to the n minus 1. The formula will always be, take a guess. Who? Nope. This is not linear. It's exponential. It's exponential. Do not multiply a sub 1 and r together to simplify the formula. Put parentheses around any r that is a fraction or decimal. Just put parentheses in general, just to be on the safe side. There is another formula like I did yesterday with the p. Same idea here works. Same concept, same idea. All right. So find what is indicated for each geometric sequence. A sub 1 equals 2, r equals 4. Find the eighth term. So I'm looking for a sub 8. A sub 1 is 2. R is 4 to the 8 minus 1. This is the eighth term. And you can type that in your calculator. And you get 32768. 32,768. Any questions about that? The next one, find the fifth term for the following sequence. What's my common ratio? Negative 1/4. That's R. So a sub 5 equals negative 1, negative 1/4, 5 minus 1. And it gives you negative 1/256. When you type it in the calculator, you're going to get a decimal. Hit math frac, and it turns into a fraction. Now, if you use a fraction bar, it should have gave you a fraction. Okay. If you don't use a fraction bar, just hit math frac, and it should turn it into a fraction. All right, write the nth term formula, or the equation for the sequence given here. So at what's a sub 1? What's R? What? Negative 12. Okay, so that's really all you need for that formula. So you would say a sub n is 3, negative 12 to the n minus 1, and you leave it just like that. There's nothing else to do there. There's nothing else to simplify. Okay. Any questions about that? Okay. The seventh term of the sequence is 62,500, and the common ratio is 5. What is the first term? So we're going to set this up. We want to know what the first term is. Common ratio is 5 to the 7 minus 1. So that's actually 5 to the 6, right? So we're just going to divide by 5 to the 6. That cancels. A sub 1 equals 4. Any questions so far? Okay. What is the common ratio for the sequence where the first term is 96 and the sixth term is 3? So now we're trying to find R, correct? So the sixth term is 3. First term is 96. Trying to find R up to the 6 minus 1. Right? So that's our setup. So what do we do first to solve for R? Divide by 96. 3 over 96 simplifies down to 1 over 32 equals R to the 5th power. So how do I get rid of the 5? Take the 5th root. So R equals 1/2. If you don't know how to take the 5th root in your calculator, you hit math, come down to number 5 where it has the x and the root symbol. Put a 5 in the top and your fraction in the bottom. And you get 1/2. Any questions about that? That's how you take the 5th root of your calculator. Okay. Next problem. Which term is 78,732 in the sequence of 4, 12, 36, and 108? So We have 78, 732 is 4. What's the common ratio? 3 to the n minus 1, right? And we're trying to find what n is, correct? So we divide by 4 first. Two ways you can do this. We can deal with the minus 1, or we can just deal with the n minus 1 together. Probably just dealing with the n minus 1 together. Okay, how do I get that down? Well, use ln. Okay, so now that brings this n minus 1 to the front. So I'm going to divide by the ln of 3. That should come out to a whole number. Comes out to 9. You didn't sound too confident in your answer. It's 9. 9 equals n minus 1. So therefore n equals 10. Okay. Any questions about this one? Okay. Find the geometric means for -6 and -486. What does that mean to do? Find the three numbers between them. Okay. So we have -486 equals -6r to the what? What's n? 5. Because there's 5 terms. So divide by -6. It gives me 81 equals r to the 4th. And how do I find r? Huh? 4th root. And you should get 3. Okay, so now I multiply -6 times 3. -18. -54. -162. And finally -486. Any questions? Okay. The next one. The 5th term is the sequence is 768. The 9th term is 196,608. What is the 3rd term of the sequence? So what do we need to find first? The r. So we have the 5th term and the 9th term. So 196,608 equals 768. This is the other formula that we're using. R to the 9 minus 5. 9th minus the 5th. So we'll divide by 768. That gives me 256 equals r to the 4th. So we'll take the 4th root to find out what r is. And r equals 4. Now I have the 5th term. Who am I looking for? 3rd term, right? So I just divide by 4 to go backwards. And if you do it twice, 3rd term equals 48. Could I have used the formula to find that? Yes, I could. So I would have taken 768 equals the third term, sorry, 4 to the 5 minus 3. And I would have solved that. And that would have just been divided by 4 squared. And it would have gave you 48. The reason why I'm showing you the formula is because you might have something that they're not so close to each other where you can't just divide quickly. All right, any questions about those two? All right, the finite geometric series. It's the indicated sum of a finite geometric sequence. What does the word finite mean? There's a fixed number of terms. Okay, there's a set number of terms. So this is the sum of n terms, your first term, common ratio, and the number of terms. All right, put that on the end of that. So you have two formulas that we're going to look at when it comes to series of geometric form, the finite and the infinite. The finite, the formula always has S sub n. For infinite, you'll see the formula just has S. And there's no n involved because there's no fixed number of terms. Okay. What is the sum of the first 7 terms of this series? -6, 12, -24, and so on and so forth. What makes it a finite series? Because it has the first 7 terms. That makes it finite. Okay. So S sub 7 equals, what's your first term? What's R? -2 to the 7th over 1 minus -2. All right, so we'll type this in the calculator. Notice that I typed it in exactly the way I have it on my paper. Okay. Put the parentheses around that R value, because if you don't, your calculator is not going to do the correct order of operations. It's going to do 2 to the 7th instead of -2 to the 7th. And you get -258. What would be the formula for this, the nth term formula for this sequence? Just as like a sidebar, real quick. What would be the nth term formula for that? To the n minus 1, right? Okay. What are you adding up? The first 7 terms. So that from the first term, n equals 1, to the seventh term, correct? So you can do it the same way in the calculator by using the summation. If you No, I was just showing you another way to look at it. If you write the interim formula. Anywho, because then look at what you have in example B. So alpha window number 2 is 4 to 16. And we can put those in the calculator. My calculator is still in sequence mode. So okay. The next one, the sum of the first 8 terms is 39,360 and the common ratio is 3. What is the first term? Now these problems can be a little lengthy when it comes to solving because that formula is so large. So three to the 8th over 1 minus 3. So I just need to solve this. So I need to do what first? By multiply by negative 2. Okay. And now what? Divide by 1 minus 3 to the 8. And you get a sub 1 equals 12. Be sure you follow the correct algebra steps for these problems. Okay, so the first term is negative 3 and the common ratio is 4. How many terms were added together to get a sum of negative 16,383? So I set up in my formula, negative 16,383 equals negative 3 times 1 minus 4 to the n over 1 minus 4. So what do you notice here happens? What's 1 minus 4? So they cancel each other out. So what should I do now? Subtract 1. You cancel out the negatives. ln. So bring the n down, and now just divide by ln of 4. So n equals 7. Any questions about those? You guys okay on those problems? Huh? Yeah. Mm-hmm. All right. The last section, an infinite geometric series. What does infinite mean? Right, it's unlimited. Okay. And I know this might seem like a strange idea, but just because you have an infinite amount of numbers does not mean they can't add up to a single number. Okay. So this is the indicated sum of an infinite geometric sequence. Okay. So we're going to add up an infinite amount of numbers to get a single value. Where it's represented by the following formula, S equals A sub 1 over 1 minus R, where the absolute value of R is less than 1. What does that mean? Yeah. It has to be a fraction. R has to be between -1 and 1, and R cannot equal 0. If the common ratio R does not meet the above condition, then the sum does not exist. D&E does not exist. And this is quickly identifiable if the numbers are decreasing in size. So, and we'll talk about this more, the does not exist part, when we get to Unit 10, because it deals with convergence and divergence. And we'll talk about that later. You guys ever seen the movie Divergent? Okay. And we'll talk about that movie too when we get there. All right. So find the sum if it exists. So looking at these numbers, what is your R value for the first one? What? 1/4. R is 1/4. So therefore, my sum does exist. It meets that condition. So my first term is 2 over 1 minus 1/4, which is 2 over 3/4, which is 8/3. And that's your answer. What about this one? What's your R value? 3. So D&E, your R is 3. It doesn't meet our condition. What about this one? What's R? 1/2. Remember, this is your nth term formula, right? So your R is 1/2. So therefore, it has a sum. Now you can't type this in the calculator, so don't try. You have no infinity symbol. Okay. So, yeah, y'all were going for it. I saw. So your first term is 5, right? According to your nth term formula. So we still do it the same way. 5 over 1 minus 1/2, which is 5 over 1/2, which is 10. So that's your answer, 10. What about this one? What's R? Does that meet my condition? So D&E. Huh? All right, B. The sum of the series is 81. Its common ratio is 2/3. What's the first term? So 81 equals a sub 1 over 1 minus 2/3. And that's a sub 1 over 1/3. right? So just multiply both sides by 1/3. So a sub 1 equals 27. Okay. What is the first term in the series? Well, the first term in the series is -34. The sum is -42.5. What is the common ratio? Set it up in your formula. How do you solve for a variable when it's in the denominator? Switch it. So 1 minus r equals 0.8. So I will subtract 1. Negative r equals -0.2. So r equals 0.2 or 1/5. The next one is fun. Any questions about those three? Yeah, that's fine. Unless all the answer choices and fractions, then you have. I think the test for this unit is multiple choice, though. Probably not. All right. Next problem. There we go. Rewrite 1.42 repeating as a series, then determine what fraction it equals. Okay. How many of you have actually took a repeating decimal and written it as a fraction without using a calculator? Somewhat. So we have 1.42, 42, 42, 42, and so on and so forth. Correct? The only reason I take more time on this problem because I have to explain how it works. So I'm not really concerned about the 1 right now, so we're not going to worry about that. We just want to deal with the decimal portion. So you have 42, 42, 42, 42, 42. So what is this? What place is this? So that's 42 over 100. What place is this to? 10,000. What is this one? It's a million place. Well, what's happening? What's my common ratio between these values? 1 over 100, right? Okay, so my R is 1 over 100. What's my first term? Okay, is this going to ever end? No, it's an infinite series now. Okay, so you have your first term and your R. That's all you need to find the sum of the infinite series, right? So you have 42 over 100 over 1 minus 1 over 100. Okay, that's 42 over 100 over 99 over 100. What happens to the 100s? And that just leaves you with 42 over 99. Does that simplify? What does it simplify down to? In fraction form. What? So that means this is 1 and 14 over 33 as a fraction. That repeating decimal, 1.4242, is 1 and 14 over 33. Yeah, I was just writing it out to explain it. Not always over 100. It depends on how many decimal places. Like, let's say it was, then that's 1,000, right? So it would be that. your common ratio would be 1 over 1,000. But until it's been explained, you wouldn't know what to do with that. But yeah, that's the answer. Or it's 47 over 33. Most of the time, you're going to see the answer like this as an improper fraction. So this would probably be the answer that's more common. You guys remember how to try to mix numbers to improper fractions? Okay. Huh? All right.